Hello, welcome to the second session of this class. So today we'll talk about IP addresses and DNS. Some key terms for today: IP address, domain name, DNS, URL, HTTP, HTTPS, and yes, that's it. So learning goals. By the end of this class, you will be able to tell me what an IP address is. You'll be able to tell me what a domain name is. You'll be able to explain in broad strokes how DNS works, what a URL is, and the difference between HTTP and HTTPS. So now, imagine this. There's a really cool viral video on YouTube, and you want to watch it. Me, I want to watch it on my laptop. But how does my laptop know exactly where to go? How does it find the correct server? So here's an AI-generated image. We'll return this question in a little bit. First, let's talk about IP address. First, what is an IP address? By the way, IP stands for Internet Protocol. So the internet has some rules for how things get exchanged. So that's the whole entire Internet Protocol. Imagine this, forget the internet. I want to mail a letter to you, personally. What do I need for it to arrive in your hands? How does the mailman know exactly where to deliver the letter? Well, the mailman would need, of course, your home address, like this. So every device that's connected to the internet has its own unique address. This is known as an IP address. My computer has an IP address. My smartphone has an IP address. Your tablet has an IP address. Just like every house has an address, every device on the internet also has an address. For example, looking here, 142.251.46.255. Although I made this address up, notice one thing. For those of you who've taken my other class about data representation in binary, notice that these four numbers are all less than or equal to 255. Why might that be the case? One moment. Well, anyway, so actually, while I was recording this, I got interrupted. So anyway, let's rewind. Back to the beginning. Every device that's connected to the internet has its own device, has its own address known as IP address. Okay? And if you look here, so I made this IP address up, but notice, why is it that everything is less than or equal to 255? If you were in my other class for data representation, you'll know that 255 is the highest number that 8 bits can hold, which means that this is 8 bits, 8 bits, 8 bits, and 8 bits. An IP address has 32 bits. Well, version 4 does. So, without getting into too much detail, version 4 was the original version, and there's version 5, of course, but it wasn't really widely used. Version 4 could hold billions of IP addresses, but the problem is, now, with 8 billion people on the planet, multiple people hold multiple devices each. We're running out of addresses. So the IPv6, IP version, Internet Protocol version 6 has more. So check out this picture. So this is a very lovely AI generated picture of a bunch of normal homes in the United States. And you can see all those numbers. Those are addresses. Just like that, every device in your home has an address, an IP address. That's how you know specifically what it is. So again, here's another example. You can actually find out your own device's IP address by going to this website. Whatismyipaddress.com. So here's some questions. Why do devices need IP addresses? Could two devices on the same network have the exact same IP address? What problems might happen if they did? Go ahead, pause the video, answer them. So devices need IP addresses to identify them to the network, to the internet, etc. It is not possible for two devices on the same network to have the same IP address. And if they did, well, a router could be very confused. Just like a mailman would be like, there are two 123 main streets. Do I put this letter here or there? Here or there? Might cause some problems. Some domain names. First, what are some websites you go to regularly? For me, here are some. Instagram.com, YouTube.com, NewYorkTimes.com, Economist Magazine, so Economist.com and more. So it's probably pretty easy for you to type in like Instagram.com or Facebook.com or something. Imagine typing this instead of Google.com. So no, this is not actual Google's IP address. I made it up. Okay. It would be very difficult. Most people would forget it or at least get a few numbers wrong. It'd be really annoying. Instead, we use Google.com. This is a domain name. A domain name is a human-friendly name for a website. Technically, it is not required. The internet technically could function without them, but remember, we're human beings. We're not calculators. It's very hard for us to memorize dozens and dozens or thousands of random numbers for no reason. What's this? Google logo. What's this? Amazon. What's this? Netflix. So instead of typing a bunch of numbers, you go to netflix.com, amazon.com, google.com. Next topic is this. What is it? DNS. DNS stands for Domain Name System. Make sure you memorize that. So how does it work? Basically, the DNS translates from English words, such as google.com, into some sort of number. Here's an analogy. How about you? Do you have a smartphone? I do. I have a bunch of phone numbers in it. So this is an AI generated image of some simulations. Yeah, you could probably memorize all of their numbers, but I feel like that would be a hassle. Instead, you have your phone memorize the numbers and then you say, call grandpa or call grandma. So did you memorize the phone numbers of everyone in your contact list? Of course not, but you know all their names. Here's what you did instead. You know the names of the people you want to call? Your phone knows the numbers. You can say, call dad after summoning his Siri. Your phone will end up calling dad's number. So it works like this. So here are some questions. Pause the video, answer them on a piece of paper. Why do you think the DNS exists? Would you rather memorize names or numbers? What would happen if DNS stopped working suddenly? So one, the DNS exists to make things easier for humans. I don't have the addresses of Facebook, Instagram, New York Times memorized, but I do know their names. Okay. So anyway, what would happen if DNS stopped working suddenly? Well, there would be chaos, but the internet technically could still work, but humans would be scrambling left and right to get the right addresses in. So what is a URL? First, let's go over the anatomy of a URL. You've been to YouTube before. You know it goes like HTTPS, blah, 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 youtube.com. HTTPS is the protocol. YouTube.com is the domain name. Okay. Exercise. Look at these. Write down the protocol and the domain name. Probably pretty easy for you, but go ahead. Pause the video and do this. What's URL? URL stands for Uniform Resource Locator. Uniform because it's the same format all over the world. A URL tells your browser where a resource is located. So youtube.com, that's the home page, and then some specific video would be like this. So again, the anatomy of a URL, HTTPS colon / / that's the protocol. www.youtube.com, that's the domain name, and / watch, and then the actual video, that's the page you're trying to visit. Did you notice the S at the end of each protocol? The S stands for secure. So if you notice any website that has HTTPS with a green lock, it is secure, right? So it's encrypted. What is HTTP? So HTTP stands for Hypertext Transfer Protocol. So every website, every page you visit is hypertext, right? And HTTP is a set of rules for how to transfer it between clients and servers. So in HTTP, information sent on the internet is sent via plain text. Make sure you memorize that term, which means that anyone can see it. For example, if your password is I live computer science, everyone can see that your password is I love computer science. On the other hand, with HTTPS, if you enter your password, it is encrypted. So anyone who's eavesdropping might look and see this, a mess, a jumbled mess. Depends on the actual algorithm used, of course. Okay, so now pause the video, answer these questions. Number one, why might encryption be important? Well, do you want people to know your social security number, your social media passwords, your credit card number? Would you want your password sent without encryption? Definitely not. HTTPS is most important when you're sending things like credit card numbers or social security, anything sensitive. Exercise, put these in the correct order. So pause the video, and the answer is B, A, C, D. Right. So we'll go up to there, and I'll do the Python in a different segment, right? Thank you so much for watching.